Okay, so let's talk about how we can take what we know about A, B, C, and D, being able to list what they do, and apply that to an actual graph, right? So I'm going to give you a function. In this case, if you take a look at the function that I'm giving you f of x. I'm saying there's this graph of f of x, and it's just any function that we want. So I just made one up. It's nothing special. But we could also apply this to ones that we do know, like squared functions, quadratics, cubic functions, radical functions, all those other ones that we know. So I'm just giving you a generic one so we can just see it happen, and then we're going to apply this to quadratic functions. So if you take a look at f of x, what I'm saying when I go over here and I'm saying negative f of x, and x plus 3 is in the parentheses and minus 1, this is my a value, right? So if I go here, this is a. My C value, right? There is no B value here. B is usually being multiplied at the beginning, and a D value. So if I were to list in words what it is that these letters are doing, I'm going to say it looks like my C value is negative 3, and that's going to move it to the left by 3. Okay, and then my A value, okay, is negative 1, and we know what that does. Remember, that doesn't move it or stretch it or shrink it. It really just reflects it over the x-axis. Okay? And then my D value, negative 1, moves it down by 1 unit. So I can say down 1 unit. Okay? So if I take these three things, left by 3, reflect over the x-axis, down by 1, I'm just going to take those and I'm going to apply them to the points that are on this graph. And we're just going to do them one by one and see how the graph moves. Okay, so I'm going to say, okay, C value says let's move it to the left by 3. So my point would go from right here at 0, negative 2. It's going to go 1, 2, 3 to the left. And then it says reflect it over the x-axis. Well, right now, where we're sitting at this point that's 3 to the left, I'm 2 units below the x-axis. So to reflect, I'm going to go 2 units above the x-axis, and that would put me here. Okay, and then it says go down by 1, so from this spot I'm going to move down by 1, and I'm going to say there's where the new point is. So if I call this point A, I'm going to call this point the new A, which I'm going to put A with a little dash here. That's what we use for transformations. Okay, and I'm going to do that for each of these points. So I'm going to say, okay, then the next point right here, which I'll call this one B, so we have a way of referring to it. It says move it 3 to the left, 1, 2, 3. Reflect it. Well, right now it's 4 units below, so I'm going to go 4 units above. 1, 2, 3, 4 puts me up here, and then I'm going to move down 1. Here's my new B, which again I'll put B with a little dash there. Okay, and now we'll do the next one. So here's C. We're going to go 1, 2, 3 to the left. Okay, it's also 4 below, so I'm going to go 4 above. That puts me up here, and then move down by 1. There's my new C, which I'll do C with a dash. And then I can do the same thing with D, okay, this last point. So I'll say it moves 1, 2, 3 to the left. It's 2 units below, so I'm going to go 2 units above, and then I'm going to move it down by 1 because that's what D tells me to do. This would be my D with the dash. Okay, so if you take a look at my new graph, so I'm trying to draw it nicely. My new graph looks the same as my original graph. It has the same shape. The function hasn't changed, but now I moved it, I reflected it. It's more left, it's more down. It's on the other side of the axis, and it's just in a different spot. And that's what we're really trying to do here, right? So we can look at these values for any function. Again, if it's a generic function like this, I can do it. If I'm talking about squared functions or cubic functions or any of those other special functions, we can take all of the special points that we know about, and we can say, okay, the parent function, here's what we know about the points, and then we can just move them, and we can kind of have a good idea about where the graph's going to be. And so this is what we're going to try to apply to the quadratic functions in the next video that you see.